Hello, and thank you so much for coming today. Why don't you tell us your name and tell us a bit about your project?
Hello, my name is Joseph Carl Hoffield. I'm a Korean War veteran, and I received my undergraduate and graduate degrees from the University of Illinois. And then I received my PhD in 1962 with a thesis on nuclear physics. I worked a number of years at Los Alamos National Laboratory, and afterwards I worked at Washington University in St. Louis. And while working there, that's where I formulated the idea for my project, the Hoffield-Keating experiment, as it's now known. So a little bit about the experiment. In 1971, I came up with this idea to test Einstein's theory of relativity using a series of cesium beam atomic clocks. My colleague, Richard Keating, and I, we left a pair of these clocks on Earth and took two other sets on commercial airline flights around the globe, one going eastward and one going westward. Um, and we then compared the times of the clocks when we got back to see if there was any disagreement between them to prove Einstein's theory of relativity.
Oh, awesome. Well, what were you guys really trying to do or find with this experiment?
Our overall goal for the experiment was to prove Einstein's theory of special relativity by using different measurements from the rate at which time passes in an airplane to which it would pass here on Earth. And general relativity's prediction of gravitational effects had been previously confirmed a number of years beforehand using subatomic particles. But we hope to test this using macroscopic clocks, sort of as Einstein kind of envisioned.
Oh, okay. Where did this project actually occur then?
Well, our experiment took us around the world twice, matter of factly. But our home base for this experiment was where my colleague Richard Keating worked at the National Naval Observatory in Washington, D.C. That's also where we left our other set of clocks on Earth. And once we flew around the world and came back, we went back to the lab there to see if the times matched up.
What other significant events were happening around the world at the time of your experiment?
Well, 1971, it was a busy year. A lot of things were happening all around the globe. A company called Intel, they developed the first microprocessor at the time. 18-year-olds in the U.S. had just earned the right to vote with the ratification of the 26th Amendment. 1971 was also the first year Walt Disney World opened up in Central Florida. And a lot was also happening with the space race during that time. The U.S. had another successful mission, Apollo 14, which was the third successful mission to the moon. And the Soviet Union at the time was also seeing success as they launched the first successful low orbit space station.
Okay. Who else was involved in your project?
Well, our project was pretty low budget and also pretty low maintenance as well. It was only myself and my colleague, as I mentioned earlier, Richard Keating. And then the crew, I guess, would also be involved in our experiment because on the flights they gave us the flight path data and speeds and things like that, so we could sit down and do our measurements on the flights.
Very personal.
Mm-hmm.
Okay, well, out of all these members, what was your personal role for the project?
Well, the experiment was mostly my idea, and I came to Richard Keating trying to secure funding and secure a lab. And me being the physicist, I did most of the mathematical calculations and was responsible for coming up with the predictions of the change of time while on board the flight.
Okay. What impact did this project have on the physics community as a whole?
Well, I think our experiment and the success we had with this experiment impacted the physics community in a large way. It was the first time anyone had tested and proved Einstein's theory of relativity and kinematic time dilation and using clocks. Like I said, it had been tested using subatomic particles, but we were the first ones to actually have something physical like a clock that we could test.
Well, how did you come up with this idea to fly clocks around the world?
Well, that's funny you asked that. As a matter of fact, I was assistant professor at Washington University in St. Louis, and I was just gathering notes for the daily lecture one day, and this thought kind of came to me. So I just grabbed a random piece of scratch paper, couldn't even tell you what it was, and just did some quick calculations, and I did find that the atomic clocks that we had during that time were precise enough that I could measure the relativistic effects of kinematic time dilation aboard a commercial air flight.
Very interesting.
Yeah, for sure.
Well, thank you for your time here today. I don't think we have any more questions.
Awesome, thank you.